Hello everyone, welcome back to the Docker security series. Today we are going to discuss about one of the important security tool, so which is called Trivy. Okay, so before going into deeper, so we will discuss something related to the problem statement. Okay, so for example, we have a developer. Okay, so we have a developer, so who has written the Python application. Okay, so he has written the Python application. Okay, so then he built the Docker image. Okay, so he built the Docker image, and that image has been pushed to Docker Hub. That image has been pushed to Docker Hub. Okay, so then CI/CD pipeline will trigger. Then CI/CD, the CI/CD pipeline become success, and that application deployed onto the Kubernetes cluster. Okay, that application has been deployed onto the Kubernetes cluster. So seems everything is working fine. Okay, so seems like everything is working fine. Okay, so like after uh, scanning that particular image, once they have deployed, so they found out there are, for example, 300 vulnerabilities they found. They found 300 vulnerabilities. Okay, so in these vulnerabilities, there are some critical vulnerabilities as well. Okay, which is very critical vulnerabilities. So these critical by getting these critical vulnerabilities, the attackers know how to exploit them. Okay, so these attackers know how to exploit them. Okay, so now your production has been exposed, right? So where hacker can come into your system. Okay, so even though your pipeline is green, your pipeline is success, still we are getting the vulnerabilities. Okay, so how to detect these vulnerabilities? How to detect these vulnerabilities? Okay, before this particular image is moving to the production environment. Okay, so how can we move this image? Before move this image to production, we should detect the vulnerabilities. We should detect the vulnerabilities. Okay, this is where you need to use the tool called Trivy. This is where you use tool called Trivy to find out the vulnerabilities before pushing the image to the Docker Hub. For pushing the image to the Docker Hub. Okay, so consider you have written one Docker file. Okay, you have written one Docker file where you are using Ubuntu image, which is called 20.04, 20.4 something. Okay, so I have written this Docker file. Okay, they have written this particular Docker file, and this Docker file looks fine. Okay, this Docker file looks fine, right? So, but this Ubuntu image, whatever the application code is you've written, so that code is perfectly fine. But whatever this Ubuntu image, the base operating system has, there are some packages like OpenSSL, okay, OpenSSL vulnerabilities, curl, okay, um, and there are some like libraries, okay, the other packages, right? So we cannot check all these packages. For example, if the packages is around 20,000 packages, so we are the humans, right? So every time we cannot check these 20,000 packages, where you need to check whether these all these packages are having the vulnerabilities or not. Okay, so this is where they, if the developers is not like knowing this tool, so they can push the application which is having the vulnerable. Okay, the vulnerable application they'll push to production. They'll push to production. Okay, so every time you cannot go ahead and check these 20,000 packages, right? So which is huge, right? So you cannot check every time manually. Okay, that's what this Trivy tool will come into the picture to find out the vulnerabilities in all those 20,000 packages. Okay, so imagine your application has, okay, so like Python libraries, Python packages, okay, Python packages, okay, and like Ubuntu packages, this particular container. Okay, so and this has the base image as Ubuntu, right? Okay, and thousands of dependencies which needed for this base, this particular Ubuntu needs to be run, right? So in this, for example, if there are 20 packages and this has 150 packages, so one vulnerable package, one vulnerable package is enough to your attacker come into your system. Okay, so your application code doesn't have any vulnerability, okay, any vulnerability, but your dependencies are having the vulnerabilities. So where attackers can attack these dependencies, generally this attack, this if this kind of attacking on the dependencies, okay, so generally called supply chain attacks. Supply chain attacks. Okay, generally this is how the attacks will be happen. If your application is not doesn't allow hacker to come into your system, so there are some other dependencies where which has the vulnerabilities. Okay, so these kind of attacks generally we called like supply chain attack. Okay, so this is what this Ubuntu packages, curl, everything will be inside your um, uh, the image, right? So to resolve all this, to overcome all these issues, so we must go ahead and use the Trivy. We must go ahead and use the Trivy. Okay, so Trivy Trivy is an open source tool which is free. Open source tool. Okay, Trivy is a open source tool. Okay, so which is developed by Aqua. Okay, which is developed by Aqua. So this Trivy is recently acquired by like TFSec. Okay, now there is no TFSec, so we should use the Trivy only. Okay, so for Terraform scripts. Okay, so this Trivy scan your container images. It will scan your images. It will scan your IAC infrastructure as a code like Terraform files and KTS manifest files. Okay, it will scan your Docker files. Okay, it will scan your GitHub repo. Okay, and it will scan your secrets as well, and dependencies, licenses, everything it will scan. Licenses, configurations, it will scan these things. Okay, so like it is manifest files, help charts, it will scan all this. uh, components. Okay, so how this Trivy is going to work? Okay, how this Trivy is going to work? Okay, so generally Trivy, this uses Trivy uses one of the database. Trivy uses um, uh, the database which is having the vulnerability information. It will store all the vulnerability information. Okay, so Trivy uses this vulnerability database. Okay, so how this database has been built? This database has been built with multiple security advisors. Multiple security advisors. Security advisors. Okay, so generally people think this database is national vulnerability database. Okay, not accurate actually. Okay, so this Trivy will use this database to compare the installed packages, and for to know the vulnerabilities, inside the installed packages. Okay, so this database has been built with the multiple security advisors. Okay, from other trusted sources. So they build this database from these components. Okay, so multiple security the advisors, like, so then generally we will call vendor security advisors. Okay, so like vendor uh, security advisors are called like Ubuntu, um, uh, like a Red Hat, like National Vulnerability Database. Okay, so and GitHub security advisors. Okay, and then Amazon Linux, they'll use Amazon Linux security advisors. Okay, all is they'll use like Debian, Alpine. They'll use all these vendor security advisors. Okay, so these advisors will help us to like reduce uh, uh, the risk, reduce the risk. Okay, so that's what it is going to work actually. Okay, so like, so what this Trivy will do, so this Trivy will download this particular database. Okay, this database and cache it into this machine. Okay, so this download this particular database and it will cache it into your machine. So because it will be downloading from the all the from the vendor, it will be automatically updating from this all the vendors. Okay, so like that's what, like like so once you download this DB, so it will cache it into in your machine for 6 hours. So after 6 hours, if you run Citrivy, again it will go and download the database again. Okay, so and sometimes it will this um, vendor security advisors will solve the false positives as well. Okay, so for example, you have Ubuntu. Okay, so Ubuntu as the OpenSSL. Okay, OpenSSL. Okay, so then you scan this. Okay, so like for example, Ubuntu, this like vendor security advisor of Ubuntu saying that there are no vulnerabilities, but this NVD, National Vulnerability, is saying there are some vulnerabilities. Okay, so but Privy trust this particular Ubuntu security advisor. Okay, because maybe this Ubuntu already fixed the vulnerabilities, already patched that particular vulnerability issue, which this NVD database doesn't done. Okay, that's what this Trivy trust this Ubuntu advisory. So and it will make it as false positive. Okay, so false positive means um, there is no issue, but it detected as a issue. So, but Trivy consider it is false positive. It is not a true. It is not an issue. Okay, that's this is where every DevOps engineer must understand. Okay, so so that's what the Trivy will use this many advisories, vendor security advisors. Okay, so this is how this Trivy will work. Okay, this is how this Trivy will work. Okay, so like so once you use Trivy, for example, Trivy image, and then the name of the image. Okay, so the name of the image. Okay, so what this will do, okay, so it will extract all the layers. The Trivy will extract all the layers like OS packages, okay, application packages, okay, application packages, dependencies, um, and then it will compare this with the DB vulnerability, the DB vulnerabilities. Okay, then it will compare this particular database vulnerabilities, known vulnerabilities, and then the Trivy will generate the report. Then the Trivy will be generating the report. Okay, generally we will share this report with the security team, um, like with the developers. This is where we are getting this these vulnerabilities. Okay, okay. Now, how to install the Trivy in your machine? So if you are using Mac, so Brave install Trivy. So it will go ahead and install the Trivy. Okay, so once we install this Trivy, so we need the Docker file. Okay, so I'm just using vim, so Docker file one, Docker file one. I'm just using this Docker file. Okay, so this is what I just want to use. Okay, so and then I just want to build this image like Docker build hyphen t f, and then Docker file one, and then dot hyphen t Trivy Trivy demo version. Okay, so this has built. Okay, so now let me Docker images. Okay, this image has been built. Okay, this image has been built. Okay, so what we will use, like we will use Trivy, and then the image we are going to scan the image. So that's what I am using image. So let me copy this, and what this will do, so this will scan whatever the like the images. Okay, everything that particular images. On top of that, like so, for example, this particular image has Flask, the Python code, and the base has Ubuntu, and the Ubuntu as a Linux operating system, right? So this Trivy will scan all these layers. Like so, let me scan. So it has been. So see, you can see there are no critical vulnerabilities. There are two vulnerabilities. Okay, so for your Python code, so it is saying Flask metadata 3.1. Okay, so now if you see requirements.txt, we are using 3.1.0, but it is suggesting to use, if you want to fix this vulnerability, you must go ahead and use this 3.1.1 version. 3.1.1 version. Okay, so like this is the Trivy is scanning all the well, like the libraries, the OS related uh, the OS related libraries, packages, everything you can see. So if you want to filter, like so hyphen severity critical comma high. Okay, we want to ignore the low vulnerability. See, it is where the critical vulnerabilities are listing out here, right? Okay, so okay. So for example, if you want to can only OS related pages. Okay, so it will scan only related to OS packages. OS packages. It will scan only OS related packages. Okay, so if you want to scan only the libraries, okay, so we just use the library. Okay. We'll scan only the library. We are using third-party library, so it doesn't have much vulnerabilities over here. Okay, so for example, if you are using any CI/CD pipelines, right? So in the CI/CD pipeline, if it find out any the critical vulnerabilities, high vulnerabilities, at that time my pipeline should fade. Okay, so what step you will write using Trivy? So you must use Trivy. So I'm just executing on the command line. So in the coming video, so uh, we will use the GitHub Actions CI/CD pipeline. So where we can use this particular command. Okay, so I'm just what I can do. So I'll just use the previous one, severity high. I'm just using the critical one and hyphen exit code one. Okay, so if it find out any vulnerabilities which are related to critical, so it, uh, it automatically see there are 55 critical vulnerabilities. All are from the base image. Base image. So we are using the Docker file one. Okay, so in this we are using Python 3 1.3. The Python 3 point image has another base image, right? While building that image, they were using another base image, right? Which is um, which is uh, Debian image. Okay, So that's what it is saying. So this is the Debian issue. So you can see there are issues related to Debian. So Debian 13.6, which has 55 critical issues. Okay, which is having, see, the libraries which are not having any the vulnerabilities. So the base image which is using by Python, so that image has the critical vulnerabilities. That particular image has the critical vulnerabilities. Okay, so for example, um, uh, like so if you have like we found out one of the issue, right? So let me, okay, so um, we have find out multiple vulnerabilities. Okay, we have find out multiple vulnerabilities. Okay, so where I cannot fix all the issues. Okay, I cannot fix all the issues, all the vulnerabilities at the same time or immediately. Okay, so because some vulnerabilities require application code changes. Okay, some vulnerabilities required application code changes. Okay, some vulnerabilities required upgrading the vulnerabilities. Okay, upgrading the vulnerabilities. Sorry, libraries. Upgrading the libraries. Okay, so like so this application code change should be done by the developer team and this some operations team, right? So like so when Trivy suggested this is what the issue I found out. So you cannot go ahead and fix that issues all immediately. Okay, so we should wait and to discuss within the team. So then only we can perform the changes, apply the changes. Okay, so so for that, like so for example, you are using a Flask 1.3.1, okay, or any Java Web Token Service like which is related to 1.8 version. Okay, so these packages are vulnerabilities. Okay, these packages are vulnerabilities. Okay, so critical vulnerabilities. Okay, so if Trivy find out those vulnerabilities, so Trivy also suggested the fix. So with the specific version, so 1.9, 1.3.2 of Flask. Okay, so like can DevOps engineer go ahead and fix this issue? So no, right? So because this is completely related to developers, right? The developers need to check. Okay, we will share this report with the developer. This is what the Trivy is suggesting. This is what the Trivy report. Okay, then the developers must verify this particular newer version will be supported by our application or not. So if like this particular version will break our application or not, so any API changes need to be done for this particular version. So and any the code changes required for this particular version upgrade. So this is where the developers and DevOps team will work together. Okay, so this is where the developers and the DevOps team work together actually. Okay, sometimes you cannot fix there might be some vulnerabilities which you cannot fix it, right? So like those they generally will called unfixed vulnerabilities. Okay, like unfixed vulnerabilities like you updated your packages, but that vulnerability still exists. That vulnerabilities still existed. It means so patch happened, but still that particular vulnerabilities remain exist actually. This is what the vulnerability is called, unfixed vulnerabilities. This is called related to unfixed. Okay, so for example, if you have OpenSSL version. Okay, so you installed 1.3.1, you scanned it, but the Trivy is saying like the fixed version is not available. Like, so it is a kind of unfixed. So you updated this package, but still it is saying that there are some vulnerabilities. Okay, so at the time those vulnerabilities generally called unfixed vulnerabilities. Okay, so generally people think that like once you fix that issue, that will be a permanent security fix. Okay, so because in a security, you never reach this 100% secure percentage actually for your applications, because it is a continuous process. Security is a continuous process to reduce your attack risk. Okay, reduce the risk. Okay, so it is always the continuous process to reduce this particular risk. Okay, so there are some mitigation things which we need to follow. Like so so you need to assess the severity, like what is the critical, high or medium. So you need to assess the um, whether this particular vulnerability will be exploited and by the hacker. So, and this is internet facing or not, so you should be careful about this thing actually. Like, so that's what you need to assess the severity. Okay, so and for example, you have the library A, so and you should make it to library B. So this is what you need to find out all the alternatives. Like if you find out any vulnerabilities on the library A, so you need to find out the alternatives always actually. And then you need to monitor this vendor security advices. So like Ubuntu, Red Hat, Alpine. So because they'll be releasing the fixed, right? So really fixing the vulnerabilities. So you have to always monitor those vendor security advisors as well. And you this will you can also mitigate the risk. So you have to mitigate the risk. Like for example, mitigate the risk. Like for example, if you are open 24 port for all the members. Okay, so to everyone, like, so this will be a very secure breach, right? So security breach. So that's what you must use, security group, firewalls. Okay, so RBAC, network policies, those things we need to use. Okay, so you need to do this mitigation of the risk. And sometimes you need to accept the risk as well. Like, so that generally we will call the acceptance, the acceptance. Like so for example, um, we have any medium vulnerability. Okay, so we have any medium vulnerability, so it is not like exploit in any environment. Okay, so but no fix exists. Okay, so but we need to accept this kind of vulnerabilities for temporary purpose actually. So that's what people generally called risk acceptance. Okay, so developers will fix the application issues, and DevOps will fix the runtime issues, right? So once the issue has been fixed, okay. So once the issue has been fixed, so they like, so for example, we are using the Spring Boot 2 application, so we upgraded to Spring 2 by upgrading this by fixing the vulnerabilities. So the vulnerability is gone, but somehow the application stopped working. So before deploying into the production, this latest version, so you must test do the you must do the unit test, integration test, functional test, regressional test. So all the test you need to perform. Okay, so any if it is any related to application code, so developers will fix the code. Developers will come into the picture. Okay, so if it is any application dependencies, still developers will work. Okay, so any base image related issues, so here the DevOps team will come into the picture. Okay, so any OS related issues, DevOps team will come into the picture. Okay, so this is how we should monitor all these security things which we need to follow. Okay, so this is how we need to use the Trivy for scanning the images. Okay, so uh, generally this will also scan the Trivy fs and then dot. This will also scan the vulnerabilities which are in the current directory. Like, so it will scan the file system. Okay, which will scan the file system. See, I have these files, and it scan all the files, and it find out the requirements and two vulnerabilities. One is saying 3.1, these vulnerabilities is saying those are not critical, those are very low, so we can ignore them for now. Okay, so this is how the Trivy will um, work for the scanning the images actually. Okay, so and also we can see how we can use Trivy with Terraform file. Okay, so we can see how can we write that particular file as well. Like, so for example, let me write something called um, bucket. So for example, like bucket.tf, let me see whether I can resource aws underscore s3 bucket. Okay, so studios the double quotes. Okay, and then name of the bucket, I'm just for referring my bucket. Okay, so and then must use access control list, so which is I'm just giving public read. It means I'm just enabling the um, public access. Let's see how it is going to scan. Okay, so I just write this Terraform file. Okay, so let me scan this, like, so whether what it is going to be done. Okay, so let me see what it is going to do. Okay, so it is clearly saying that it scanned the um, this particular Terraform file only. See, that's what, if you want to scan um, like Docker image, you must use that Trivy image, and if you want to scan the Terraform files, you must use the Trivy configuration. So there are it also scan like the Docker files as well. Like, so the configurations related to the particular current directory. So it find out the one vulnerabilities. So total 27 tests, and 26 are success, one is failure. So there are no critical vulnerabilities, so only failure one because of one high. Okay, so because it find out in which file you found that, like, so no public access block, so not blocking public as ACLs. So they are saying we have written this particular code, and it went and see that and to the um, onto this Terraform file, and bucket does not having the versioning and no public. So again, it is saying public read. Okay, so if you go down, this is what it is saying. Uh, Bucket is not encrypt data. So it is saying that, like, what are the best practices we should follow to create the bucket. Okay, so that's what it is going to give you the uh, um, give you the list actually. So, and for the Docker file, it is saying that at least one user must a command in Docker file with is having the non-root user, because we haven't mentioned anything, right? So that's what it is saying, use the non-root user always. Okay, so this is medium. So this is how it is going to work with the um, Terraform files as well. So we can also use um, like Kubernetes manifest files as well, like Kubernetes manifest files as well. So same way, like, so if you write Kubernetes manifest file, like use the same Kubernetes config dot, so it will um, go ahead and scan that particular manifest file, and it will tell you what exactly you need to do. Okay, so we have seen uh, scanning the Terraform files as well, right? So, like for example, we have a CI/CD pipeline is running. So, um, Trivy find out multiple critical issues. So everybody cannot go to the GitHub action pipeline and they can see the log files, right? So what generally we do, so we will generate the report and we will send it to the respective security team or developer team. So for that, so how do we generate this particular report? Okay, so Trivy. Okay, so image. So I just want to give the format. Format would be JSON format. You have Serif format as well, so you can use that. So I'm just using report.json. Okay, so and then the image name. Okay, and then the image name. Okay, so it will generate the report. Okay, so it will generate the report, and if you go ahead and see in the list, so this report has been created. Okay, so this report has been created. Okay. We will share this report with the respective security team and the development team and management team as well. So accordingly, we will schedule a meeting and we will discuss over there, and we will solve the issues. Okay, so this is how we will create a report. Like, so for example, if you want to create a Sarif report, like, so I just want to give a report dot Sarif. Okay, so I'm just changing that to Sarif. Okay, so it depends on the requirement. How can we create your reports? Okay, so this is how we will create reports in the pipelines, and we will share that report with the respect the security team. Okay, so this is how we use the Trivy for like creating the finding of the vulnerabilities onto the current GitHub repository, Terraform files, and Docker files, Docker image. So in the okay, so and there is a one more concept. So the uh, SBOM. So why do we create a SBOM? Software bill of material. Okay, software bill of material. So why do we SBOM? Why do we create this SBOM? Okay. software software bill of material, bill of material. Okay, so why do we create this particular report? Okay, so why do we need this particular particular report? Okay, so for example, uh, you build one Docker image. Okay, so you build one Docker image. This is a Docker image. Okay, so you have this particular Docker image, and in this image you have installed uh, like multiple packages like Flask, Pandas. Okay, so requests, these packages you have installed in this image, in this image, right? So this package will install more dependencies. This will install more dependencies. This will install more dependencies, right? So one package has multiple dependencies inside it. So it has more dependencies, right? It has the more dependencies. So so it may have like more dependencies means these packages have sub packages, right? This package has more sub packages like more than 50 to 100. Consider more than 50 to 100 packages. Okay, so so for example, uh, imagine the new vulnerability has been announced. So for example, there is a one package like URL lib, so to 0.1 version. So they have announced that this is the one of critical vulnerability. This is the one of the critical vulnerability. So you have built this image, but this particular image um, has this particular the package. Okay, this package. Okay, with this specific version. So and then this that vendor security advisors have been declared that this is the new critical vulnerability. This package is become a critical vulnerability. Okay, so uh, like like okay, so if you don't use this SBOM, right? If you don't use this SBOM, okay, so you will not be having only single image, right? Like you will be having lot of images in your ECR repository or any the private repository, yeah, which you are going to use. Okay, so if you don't create this SBOM, right? SBOM, so you have to go through all these images and you need to check where we are using this particular package. Okay, so where we are using this particular package, so you have to pull all these images in your local. Okay, so like you need to check all this each image you need to verify. Okay, and you need to like list the result. Okay, you need to list the result, right? So then you need to share this with your manager who asked about this particular vulnerability. So this particular package where we are using. Okay, so without SBOM, we will face this kind of struggles we will be facing. With the SBOM, okay, so what SBOM will this will generate one report where it has all the libraries, packages, dependencies, everything will be listed in this report, whatever the SBOM is generated. Okay, the like simply if you go inside this report, you can find out where or like what kind of packages we are using, what kind of libraries we are using. So what versions we are using, uh, those things we can easily find out. Okay, those things we can easily find out. Okay, so that's what the software bill of material is very useful. So that's what we will generate this particular report, and we will share with the security team or management team or management team. Okay, where it has the all the details related to our packages, dependencies, libraries, everything. Okay, so how do we generate this particular SBOM report? Okay, so how do we generate this particular um, report? Okay, so simply if you use the same command, okay, if you use the same command, like there is a format, so you must, the format would be cyclone dx, cyclone dx. Okay, and we use cyclone dx as bomb, and it will be a JSON. Okay, so let me go ahead and create that. Okay, now if we go ahead and see, this has been created, this particular if you open SBOM JSON, so you can see what kind of versions we have installed. So everything will be listed in this in this file. Okay, so this is how we this is how we generate this particular report. Now if any manager come and ask me the report, right? Like, so if manager come and ask, so where we are using this particular version, so I can simply go through this particular SBOM report, and I can find out in which image we are using. Okay, so those details we can give it to the manager. So this is how we use Trivy for generating the report as bomb, all of them. Okay, so hope this video will be helpful, and if you like, subscribe. Okay, so thank you.